All right, I want to work problem 56 out of chapter 4. It's similar to one of your homework problems. And so I have this pipe fixture, and I've got a force applied to it that he tells me the force. And he says, determine the magnitude of the moments of the force about the XYZ axis, solving the problem using a vector approach or using a scalar approach. So by the vector approach, I think he just wants the cross product. And so I wrote AB. So if my force is at B, I want my R will be A to B. I wrote be 4 in the X, 3 in the Y, and minus 2 in the Z. And then I did it by hand, so to speak. I wrote my IJK, my R, and my F. And so you go I minus J plus K, cross out row and column. So you cross out row and column, that's going to leave you 3 times a minus 3 minus 9, subtract minus 2 times 12 be plus 24. And then row and column, so 4 times a minus 3, subtract a minus 2 times a 4. So that'll give you minus 12 minus a minus 8 or plus 8. And then row and column for K, 4 times a 12, which is 48, subtract 4 times 3. Then you do your arithmetic, you get 15I, 4J, 36K, foot-pounds, and then I let MathCAD do it by just using the cross-product operator and check it, and it worked out good. Now, by scalar, he wants us to use sort of a more physical approach, and that is he wants you to think of writing your force vector in terms of its X, Y, and Z parts, and then calculate the moment of each one of these about each axis. Remembering your right-hand rule. Your right-hand rule is A cross B, but here it's more, if I'm going to, we're using the idea that if I got that pencil as my line and I want to rotate that pencil around its center, then the torque would be, if I point my thumb along the pencil, then it's going to rotate the way my fingers are curling. If that way, or if my thumb's pointing that way, then it's going to rotate that way. Or if I do it, see, really hard to get to the camera. If I do it here, if it's coming towards you, if it's coming toward my thumbs towards you and I grab the pencil, that's going to be in that direction. Or if it's going away from you, then they're curling in that direction. So the right-hand rule in that sense is what we're going to use here. So what we do is I take each axis. So what's the moment about the x-axis? Well, X is parallel, so it can't rotate about the x-axis, but the Y and Z can. So the Z part going down on that side, you'd have to grab your thumb pointing back if you want your fingers to curl down on this side. So you're going to grab this x-axis with your right hand. Your thumb is either plus or minus along there, and your fingers have to point down on the right. So that's going to force your thumb. That's going to force your thumb towards you like that. So that means that it's going to be in the negative direction. So negative FZ. And remember, we're sliding the Z around, so we slide it up to this plane, and the perpendicular distance to the x-axis is 3. Now I've already drawn the Z down. So I've already taken care of that negative sign. All right, and then the Fy can cause a rotation about the x-axis. It'd be passing underneath it. And so to grab it so that your fingers are underneath it, we'll point your thumb along positive x. So it's going to be a plus Fy, which is our 12. And then what's the perpendicular? We'll slide Fy all the way back underneath the axis, and that's 2 foot. So 2 Fy. So put in the numbers, Fz is 3. So we get a negative 9 plus a 12 times 2, and that adds up to 15, which is what we had. Or what can cause a rotation about the y-axis? Well, the Fy can't, so it's only Z and X. So the X, let's see, I did the X first. Notice to put your fingers under the y-axis, and your thumb will have to go back toward the origin. So it's going to be a negative torque that Fy. Fz is causing around the y, Fx. Fx is causing around the y, and it's vertical. If you slide it all the way back under there, its vertical distance is 2, so minus 2 Fx. And then the Fz can cause a rotation about the y, and again, you got to put your fingers down on that side, which forces your thumb along the plus x-axis. Thumb along the plus x-axis, or plus y-axis rather. to grab that y-axis one way or the other. You want to do it so your fingers follow the force on the side toward us. And so that gives us a positive torque, and it's going to be Fz times the perpendicular distance. So slide it up here, and the perpendicular distance is 4. So you add those up and you get a 4. Now, who can cause a rotation about Z? Well, Z can't because it's parallel, but the X and the Y can. And so the Fx, you'd have to point your thumb up. So you'd have to point your thumb down so that your fingers can be on the positive side. And that's going to give you a negative Fx. And the perpendicular distance is to the z-axis is going to be slide all the way back, and that distance is going to be 3. And then the Fy can cause a rotation about the z-axis. So you're going to have to put your fingers toward us. That means you'd have to point them along the force. You'd have to grab that z-axis. Your thumb would be up. So we're going to have a plus Fy times its perpendicular distance. And sliding Fy, back to where it's perpendicular to z, give you 4 feet. So I've got 4 feet times Fy. You add those up and you get 36. So you can do it a very physical way, and you can look in the book. He's got some hand pictures there too. We can always do the cross product, but probably after a few years on the job, most engineers aren't doing cross products anymore. They don't remember how, but they do know how to do this. So you want to practice it. That's for me, that's the harder way to understand it. But once you get it, then there's a lot of problems you can just kind of write down the answers to. So remember, if you got a torque, it's a vector. You're going to rotate around that vector torque or vector moment. You point your finger in the direction of the arrow, and you grab the arrow, and your thumb along the arrow. Your fingers will wrap around the way it would rotate. Okay? All right, if you got any questions, shoot me an email. I'll do another problem also.